Welcome back, I'm That Chemist, and today we're going to be deciding which chemical is the most uncanny. But first, a message from our sponsor. Today's video is sponsored by Wise Tea. Did you know that tea can be made out of coffee leaves? Wise offers many teas made from the upcycling of coffee leaves. Normally, coffee beans are only harvested for 3 or 4 months out of the year, but by using upcycled coffee leaves, Wise has been able to support year-round employment for coffee farmers. Wise is a local small business from Vancouver, Canada, with products in over 400 stores, in addition to their online store. Wise offers classic iced teas, as well as 9 dry tea flavors that come in tea bags and loose leaf, but I'm a fan of their sparkling iced tea. Their sparkling mango iced tea is my personal favorite. I sure love the taste of mango. Wise offers drinks that are a healthy alternative to juice, soda, or traditional iced teas. If you want to get your hands on some of their tasty teas, Wise is offering 20% off their Canadian and US sites when you use code THATCHEMIST at checkout. Head over to drinkwise.com and use code THATCHEMIST to earn 20% off your first order. That way, they'll know you came from here. I want to thank Wise for their support of this channel. Let's start with the Triangulanes. So, previously on the channel, we've talked about triangulenic acid as well as trianguline, which is this stable diradical compound. And recently someone brought to my attention a bunch of other molecules which also have the name triangule, and these are the triangulanes. So these molecules are constructed out of cyclopropane rings, and they have a unique type of chirality as they're spiroannulated cyclopropane rings. So here you can see they're just several different cyclopropane rings all connected together right at the corners, and depending on how you connect these, you get different types of chirality. So here we have meso 5 triangulane, we also have minus 5 triangulane, and plus 5 triangulane. Here the number 5 just means that there's 5 of these rings together, and there are other triangulanes that exist besides these 3. I personally think that the triangulanes are extremely uncanny, so why don't we put those right into S tier. S for Spiro. Okay, next we have Amabiline. Amabiline is a pyrrolizidine alkaloid which is hepatotoxic, which means it's toxic to your liver. This compound is found in the seeds and flowers of borage, also known as Boragio officinalis, and this compound may contribute to the potential liver damage caused by the consumption of borage. Now, the thing that's extremely uncanny to me is this 2 5-membered rings which are fused together, which also contains an alkene. In addition to Amabiline, we also have this other compound, Monocrotaline. You can see that these structures are almost identical, with the exception that there's another group on Monocrotaline which isn't present in Amabiline. Monocrotaline is also a pyrrolizidine alkaloid, and this is present in plants of the Crotalaria genus. Monocrotaline can cause liver, lung, and kidney damage in various organisms. And if you ask me, I think both Monocrotaline and Amabiline are both fairly uncanny. I think Monocrotaline is probably more uncanny because not only does it have these 2 rings fused together, Monocrotaline also has this macrolactone group, which makes it a little bit more uncanny. You can see how hard it was for me to draw this one. I think this one's going to have to go right into S tier, and we can put Amabiline into A tier, which is appropriate because it starts with an A. Next, we have folinic acid. This one kind of looks interesting. If you've ever seen the B vitamin folate before, this is almost the exact same molecule. We just have a formamide group coming off of this nitrogen. Folinic acid is a medication that can be used to decrease the toxic effects of methotrexate and pyrimethamine. You might be familiar with pyrimethamine from Nerd Rage's videos discussing it. This compound can also be used to treat folate deficiency. So this looks like a pretty complex molecule. I think it's a little bit uncanny to see something this big, but if you're a biologist, maybe this just looks like your typical biomolecule to you. I think that this is at least probably like a B tier. None of the groups on their own are too upsetting. I think seeing this 6-membered ring connected to this piperazine is a little bit unsettling to me. Although this is already present in the B vitamin folate, so maybe this is totally fine. You know, I didn't intend to do this, but it is a B vitamin, and I guess that's why it's in B tier. Dun, 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 boo. Okay, next we have Meralluride. I think that this compound is fairly unsettling to look at. It's a little bit uncanny, because this has an organomercury group, and it also has this weird acylated urea group. You might be wondering what this compound's for. This compound is a diuretic, which means it increases the production of urine. Some toxicity reports were published for this compound, and the people who tried it had negative experiences. One person experienced violent delayed febrile reactions after the 5th, 6th, and 7th intramuscular injections of this compound. There was also some studies in Japan that showed the compound called ventricular fibrillation in a high percentage of animals when compared to alternatives. Some of these alternative diuretics were easier to administer in increasing dosages without side effects. And so they ended up not pursuing this compound further, and this compound doesn't see any actual use. So overall, I think it's a little bit uncanny to see mercury in anything. Even though there are instances where it's safe to have mercury in a drug, it still is a little bit unsettling to me. And I think this one's probably got to go at least in A tier because it has an organomercury. It's pretty unsettling. Not quite as unsettling as our next one, peroxyacetyl nitrate. This is a compound that, if you had shown me this a year ago, I would think that you're making things up. I wouldn't think that this is real. This chemical is extremely uncanny because not only does it have a peroxide linkage, but we've connected like acetic acid to nitric acid in this one crazy molecule. This is a secondary pollutant that's present in photochemical smog. It's a lacrimator, which means it'll irritate your lungs and eyes. And this chemical gets produced in the atmosphere via the oxidation of hydrocarbons to peroxyacetic acid radicals in the presence of nitrogen dioxide. Since this chemical itself isn't directly emitted, it's a secondary pollutant. This is one of 3 major chemicals that are important in photochemical smog, as well as ozone and hydrogen peroxide. I think that this is another S tier chemical. I think this is super uncanny, and I wonder if there's more analogs of this that could be synthesized in the lab that would actually be stable. Next, we have hyperforin. You might be thinking to yourself, this molecule looks pretty foreign. You might even say it looks hyperforin.
They ask you how you are, you just have to say that you're fine when you're not really fine.
Hyperforin is a phytochemical produced by certain members of the plant genus Hypericum, most notably Hypericum perforatum, also known as St. John's wort. This is a little bit uncanny because of all of these isoprene groups, and if you're not familiar with isoprene groups, isoprenylation is something that certain organisms can do to build carbon chains out. This is often seen in the synthesis of terpenes or terpenoids. If you're interested in seeing a video about me discussing terpenes and terpenoids in the future, I might be willing to make a video on that, so let me know down in the comments. Hyperforin is thought to be responsible for the antidepressant and anxiolytic properties of the extracts of St. John's wort. Anxiolytic just means that it reduces anxiety. So this compound, it's a little bit uncanny. It's got an 8-membered ring with a bunch of isoprene groups sticking off of it. It's also got 4 ketones, or 3 depending on how you view this enol. This one's uncanny for sure. I don't think it's too bad overall, so I think we can put it into C tier. Why don't we talk about this next one, which is extremely uncanny. This is Graphullerene. This molecule was only recently reported. You might not consider this a molecule because this is a continuous network. This is just a snapshot of part of the network. And what this is a covalent network of fullerenes connected as if it was graphene. So this was reported this year in Nature. It's akin to graphene, which is an extremely strong material, but instead of benzene rings, we have entire buckyballs, also known as fullerenes. Here's some pictures of what this looks like from their paper. And if you're wondering how the authors made this, what they did was they heated C60 fullerene with magnesium powder at 600 degrees Celsius. I'll include a link in the description to the paper where they prepare this. I think this is extremely uncanny, but if this ever gets used to make some cool super materials, I would be really interested to see what they could do with it. So this one's pretty unsettling. I think the fact that this has been made is pretty awesome, but it's still unsettling. Why don't we put it into A tier? So if you thought that one was unsettling, just wait till you see the next one, Calicheamicin. Calicheamicin is a member of the diene anti-tumor antibiotics, which is derived from the bacterium Micromonospora echinospora. The group of calicheamicins target DNA and cause strand scission. So what this molecule does is it binds with DNA at the minor groove, where these essentially do a Bergman cyclization reaction to generate a diradical species. This diradical is a 1,4-didehydrobenzene, and what this can do is it can abstract hydrogen atoms from the deoxyribose sugar backbone of DNA. If you're wondering why this molecule could be considered uncanny, I'd say this molecule is completely gilded in uncanny functional groups. Just pick anywhere to look and you're going to be a little bit overwhelmed. Here we have the 6-membered ring, which is a cyclohexanone, being forced out of its desired geometry with a trisulfide. Here we have an alkyne-alkene-alkyne with this other carbamate group here just totally hanging out. Then we have 2 sugar groups, which are totally fine, till you notice how this sugar is connected to this other sugar through a hydroxylamine linker. Finally, we have a thioester on a hexasubstituted aromatic ring connected to yet another sugar. This molecule is extremely uncanny to look at, and believe it or not, this one even has a reported total synthesis. This chemical displays unbiased toxicity to bacteria, fungi, viruses, as well as eukaryotes, which raises questions about how anything can even make this and then stay alive. The way that this is thought to work is that there's a self-sacrifice resistance mechanism encoded by the gene CALC from the Calicheamicin biosynthetic gene cluster. And what some scientists figured out in 2003 was that Calicheamicin is able to cleave the CALC site specifically, which destroys both the Calicheamicin and the CALC protein, which prevents DNA damage. So this bacterium not only produces the poison, but it also prevents itself from being poisoned. This molecule is super uncanny. It's got 4 sulfurs in it. It can go right into S tier. Okay, next we have Miroestrol. This compound is a phytoestrogen, which means it's a plant-derived chemical that mimics the biological activity of the hormone estrogen. Miroestrol was first isolated from the Thai herb Pararia mirifica in 1960 and was thought to be responsible for the rejuvenating properties of the plant. Now, there are some naughty nuggets out there who are reporting that this compound can be used in dietary supplements to lead to breast enhancement in women. However, there's lack of conclusive evidence for such claims, and the FTC has taken legal action against marketers for these unproven claims. So, I know what you're thinking out there, but don't do that. Okay, so this molecule's got some interesting uncanny structures to it. It's got a benzene ring with this dihydropyran ring connected to it, but we also have, in addition to the steroid core, which is essentially what this is here, we have another 5-membered ring connected to this. So this is like a super steroid. This is a little bit uncanny. I wouldn't want to have to make this. This looks like it would be a lot of work. I think we could probably put this one into like B tier, because while it's a little bit uncanny, it's not uncanny compared to some of the other ones we're going to be talking about. Next, we have this one, Nevirapine. Nevirapine is sold as a medication to treat and prevent HIV and AIDS, specifically HIV-1. This is a non-nucleoside reverse transcriptase inhibitor, and if you don't know how HIV works, it works using this protein called reverse transcriptase. What this does is, instead of using your typical transcriptase, where you'd be converting DNA into RNA and encode RNA, what a reverse transcriptase does is it takes RNA and it encodes it into your DNA, changing the DNA of that cell permanently. So what this drug does is it targets the reverse transcriptase protein that HIV-1 makes, which is a retrovirus, and it just prevents the function of that enzyme. This compound has a tricyclic lactam scaffold with a cyclopropylamine group, and when I look at this, I think that this looks a little bit like loratadine, also known as Claritin. So this compound's a little bit uncanny. I think compared to the other ones, this is not too bad. I think we could probably put this into D tier. Next, we have Hypericin. I like Hypericin. I think this is a kind of cool looking one. This molecule is basically a graphene fan fiction. This compound is an anthraquinone derivative, and similar to Hyperforin, this is found in St. John's wort. This is believed to be one of the principal active components of St. John's wort as well. So this is uncanny. There's way too many rings going on here. I think this one can go right into S tier as well. It's pretty uncanny. Another molecule which is oddly uncanny is JWH176. So you might look at this and think, this probably does nothing. This looks like oil tar. This is just carbon and hydrogen. But believe it or not, this is an analgesic drug, which is an agonist at the cannabinoid receptor. So this has similar functionality in the body to THC. This was discovered along with a lot of other compounds from John W. Huffman, an organic chemist at Clemson University, who synthesized a bunch of chemicals that affect the endocannabinoid system. Now, while I'm sure you've heard of THC before, you might not be familiar with anandamide, which is another really crazy molecule, which is the first endocannabinoid that was ever discovered. So this looks quite different. However, if you've ever seen any of the other JWH compounds before, such as JWH175, you'll see some structural similarity, where JWH175 has an indole ring, where this instead has an indene ring. Another compound which is more well known is JWH018, which is a naphthoyl indole, and this has been found in the street drug Spice, which is usually some sort of mixture of a herbal medium that's been sprayed with synthetic cannabinoids. So this compound I think is pretty uncanny because it's a drug with no oxygens or nitrogens, no other heteroatoms in it. It's just entirely carbon and hydrogen, which is pretty wild. I think this one can probably go into B tier because the structure itself isn't too cursed. It's just pretty uncanny when compared to other cannabinoids. The next molecule we have is Xylindein. Xylindein is a quinone pigment that's produced by fungi in the genus Chlorociboria. This pigment is what causes the green staining in wood affected by the fungi. So this molecule overall, it's got a lot of rings all in a row. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 rings all fused together. I think synthetically this one might be challenging to synthesize, although there is this whole dimeric structure to it. So there's a bit of redundancy to its structure. So this one's definitely uncanny as well. I think this one can go into S tier because there's just so many rings there, and that would be awful to make. Here's an interesting one you might not have come across before. This is called Quinhydrone. This compound forms when you have a 1-to-1 mixture of 1,4-benzoquinone with hydroquinone. And this compound is used as an electrode for determining hydrogen ion concentrations in unknown solutions. This was principally used as a photographic developing agent. And in my research, I've inadvertently prepared this before when I was trying to prepare 1,4-benzoquinone from hydroquinone using various oxidants. This compound actually crystallizes as a dimer, and here's a picture of what that looks like. This isn't my picture, this is just one I found on the internet, and I think that the crystals that this thing forms were very beautiful. This compound's uncanny because it's kind of not a compound, it's kind of a complex, and I'll put this one into A tier. Let's talk about Agelongine, or Agelongine, depending on how you want to pronounce it, is a bromoperol pyridinium alkaloid that was isolated from the sea sponge Agelus longissima. This compound has demonstrated anti-serotonergic effects on the stomach of rats. This compound is a derivative of niacin, which is one of the B vitamins. So this has a charged pyridinium group, and the carboxylic acid is deprotonated, so this is a Zwitter ion. A Zwitter ion is when you have a charged molecule, which is also net neutral. So here we have a positive charge, here we have a negative charge. The whole thing's neutral, but it's still got charged groups, so that means it's a Zwitter ion. I personally don't think that this one's too unsettling, but if you're not familiar with seeing Zwitter ions, this one might upset you a little bit. I think we can put this one into like D tier because it's not too bad, but it does still have a Zwitter ion, so a little bit strange. Speaking of bromoperols, why don't we talk about Longamide B? Longamide B was isolated from Agelus salonica, and this compound displayed antibiotic activity against gram-positive bacteria. Now, while this compound's name is longamide, I think that this shouldn't be called longamide because it's actually a lactam, not an amide, and this compound isn't very long, it's pretty short. So I would propose that instead of calling this longamide, that we should actually call this short lactam. This one's not that unsettling. I think that this one can probably go into like E tier. There's nothing too unsettling about it other than the 2 bromo groups right connected to the perol ring. Here we have Lamotrigine, or Lamotrigine if you prefer. This compound's sold as a medication used to treat epilepsy and stabilize mood in bipolar disorder. This compound has a lot of nitrogen relative to the amount of carbon it has, and I would have some slight concerns that this compound might be a little bit unstable. This has a 3,5-diamino 1,2,4-trizene core, and that's a lot of nitrogen all in one ring. I think that that is definitely uncanny in terms of being upsetting, unsettling. I think this one could go into B tier because that's a lot of nitrogen for one small molecule. Here we have nitromemantine. This is an adamantane-containing compound with both an amino as well as a nitrate group. This compound is a derivative of another chemical called memantine, which was developed in 2006 for the treatment of Alzheimer's disease. This compound has been shown to reduce excitotoxicity mediated by overactivation of the glutamatergic system. And so this thing blocks NMDA receptors. This has a nitrate group, which is always a little bit uncanny because it is reminiscent of nitroglycerin, but it's still a little bit uncanny, so I think we could probably put it into like C tier, but it's not too bad. Here we have Atractyloside, and maybe you'll be attracted to this glycoside. This compound features 4 rings in one portion of the molecule, and then on the other part of the molecule, where we have the glycoside, we have 2 sulfate groups. So this compound's been sulfonylated. This is a toxic glycoside that's present in numerous plant species worldwide, especially in the daisy family. Exposure to this compound by ingestion or physical contact is toxic, and it can be fatal for both humans and animals, usually through kidney or liver failure. These things have been used as poison since at least 100 AD, although it wasn't characterized and isolated until 1868. There were a few high-profile accidental poisonings in Italy and Algeria in the mid-1950s, and this renewed interest in this compound in research. So this compound's definitely a little bit unsettling. Nature produces this weird disulfate, and this compound's killed some people, and so this is not a good compound. This is definitely a little bit uncanny. I think we could put it in B tier. It doesn't sketch me out as much as some of the other ones here, but those 2 sulfate groups are definitely uncanny to a synthetic chemist, since we don't usually synthesize stuff like that. But it's nowhere near as uncanny as our next one, phytic acid. Phytic acid is essentially a molecule that plants use to store phosphorus. This is a derivative of inositol, which you might often see as an ingredient in energy drinks, and it's something that our body needs as a part of normal functioning. Phytic acid and phytate, which would just be the corresponding conjugate bases, display a high affinity to dietary minerals such as calcium, iron, and zinc, which inhibits their absorption in the small intestine. So this is a crazy looking molecule. Inositol on its own is fine. It's a little bit interesting to see hexahydroxycyclohexane, but to see every single oxygen on that phosphorylated is extremely uncanny to me. I think that this belongs right into S tier. Okay, we have 3 molecules left. Let's talk about Triclofos. This looks more like a nerve agent than a treatment to me, and this is a sedative drug that's occasionally used for treating insomnia. This is a prodrug that just releases trichloroethanol in the body, which is used as a sedative. An alternative drug that accomplishes the same thing is chloral, as chloral is also a prodrug to trichloroethanol in the body. Now, the one disadvantage here is that trichloroethanol can cause liver damage, and Triclofos isn't one that you should use for extended periods of time. I look at this and I see that phosphate group. It looks a little bit like a nerve agent to me, and guess what? Triclofos is no longer available in the US. So this compound's uncanny because it has a bit of an uncanny resemblance to a nerve agent. I think that this probably belongs in C tier because it's still not that uncanny compared to some of the other ones we've talked about. Next, we have Ichyothereol. This compound has 3 alkynes in a row, as well as an alkene group. And I would have thought that this is just some synthetic compound that someone made for some obscure reason, but no. This is a toxic polyione compound that's found in the leaves and flowers of several plants in South and Central America. These plants have been used in the form of their extracts due to their toxic effects on fish and have been long used by native tribes in the lower Amazon basin for fishing. While this is toxic to fish, it's also toxic to mice and dogs, producing convulsant effects that are similar to those of picrotoxin. So this chemical is a super duper toxic. It looks really simple and innocuous, but it's extremely uncanny to see 3 alkynes in a row. This is the type of thing that if your supervisor saw you making this and they weren't aware you were doing it, they would be pretty concerned. So I think this compound can go right into A tier. Last but not least, we have Sivifene. Sivifene is a small molecule anti-neoplastic agent and immunomodulator that was developed in the 2000s for the topical treatment of cutaneous cancer metastases. Initially, this might look like a really uncanny molecule till you realize that this has just undergone a condensation reaction with a benzoquinone and 2,4-dinitrophenylhydrazine, which is actually a relatively common reagent. Now, while this was used for the treatment of cutaneous cancer metastases, the actual mechanism of Sivifene is not known. So slightly unsettling, but it's not too bad overall. Why don't we put this one into C tier? So hopefully you enjoyed all these uncanny chemicals. If you want to check out more videos, we have plenty of tier lists on the channel that you could watch for hours. Thanks for watching, and I hope you have a great day.